So good evening, everybody. My name is Daniele Miorandi. I am Executive VP for R&D at UHopper. And today I will tell you a little bit about the monitoring component of a Smart Collectives Toolkit. First of all, the objective of having a monitoring component is to basically monitor the liveliness of the Smart Collective components, which might actually be deployed across multiple servers or, as the typical case, across multiple containers. The target users of this component are system administrators and platform operators. The target usage of this component is for troubleshooting in case of platform malfunctioning, having a system for easily sending out alerts and warning, possibly in the long term also supporting self-healing mechanism for allowing platform components that are not running properly to basically self-configure and heal themselves. In terms of structure, the monitoring component consists of three main modules. The first one is actually a set of modules gathering and publishing relevant information. We have then modules that consume the monitoring related information, and last but not least, an information dissemination infrastructure for collecting the information gathered by the first type of modules and make sure that it is correctly delivered to the second type of modules. The basic architecture we have for this specific implementation local agents that collect specific information that concerns the liveliness and the health status of each component, and that communicate with the infrastructure via some lightweight Java or JavaScript clients. The monitoring infrastructure provides scalable support to the collection of local agents feeds, and of course we have a monitoring dashboard which represents the main consumer of monitoring data generated by the agents and dispatched through the monitoring infrastructure. The implementation that we have chosen for Smart Collectives is based on the well-known Elastic open source stack. Some of you might actually know it as ELK stack, as it used to be called up to a few months ago. It uses the Logstash open source framework, which supports the collection of logs in various schemas and formats, and has a very large number of plugins available, so to make sure that it can basically fit most implementation of components. This, in our implementation, is coupled with Redis, so a broker, and Elasticsearch, so a database, for ensuring scalability in large-scale deployments. Actually, the usage of a Redis broker is optional, and we don't really suggest to use it in limited-scale deployments as the ones we have been using through the Smart Society project. In this slide, you see the architecture of the monitoring solution that we deployed within Smart Collectives. So, starting from the bottom left of the screen, we have on all containers or virtual machines that host the instances of the Smart Collectives components, some monitoring agents, and these are connected to a piece of code which is called a Logstash shipper, which is actually an agent that collects this data and sends it, in this case, to the Redis broker, which can be scaled in case you have a very large-scale deployment. Then this is transmitted to a Logstash indexer, where the information collected is indexed and filtered. This gets saved and stored on an Elasticsearch cluster, and from there you can actually access the information either through a web dashboard, here as we will see Kibana is the default choice, or through some custom APIs that allow you to query the log directly. So as I was mentioning before, for the monitoring dashboard, the idea here is to have something which allows you to visualize in an easily interpretable and actionable form aggregated and curated logs that are stored in the Elastic DB. And of course, platform operators can develop their own ad hoc monitoring dashboard, or you can reuse the solutions you are most familiar with, but the default option that ships with our implementation is based on Kibana, which is another product from the Elastic Stack family of products. It supports a seamless integration with Elasticsearch. It is a rather flexible dashboard with some basic analytics functionality, but we believe it's actually more than enough for a deployment of this type. Here you have an example of how the monitoring dashboard looked like. This is actually the one that we used for sustaining the pilots that we run within the framework of the Smart Society project. Now, the what and where. The monitoring component is available via the Smart Collective repository. Here you see on the slide the link. You can just go to the Smart Society group. The name of the repository is ELK-SS. It installs via Docker Compose. There is some documentation available on the wiki. And I mean, if you're familiar with this type of products, it will take you just a few minutes to get it installed, up and running. Summary. The idea here is that all containers or virtual machines or server, doesn't matter, running instances of Smart Collective's components shall integrate a Logstash shipper. The information is collected via a Logstash server. It is saved on an Elasticsearch DB, and the monitoring dashboard is provided by Kibana. We have also the option of using a Redis broker to improve scalability, but as said, this is something which should be used just in case of very large-scale deployment. So I guess 90% of you don't really need it. That's it. Thank you very much for your attention, and if you have any question or doubt, don't hesitate to contact myself. Thank you.